I'm Jenna. I'm one of Dan Dahlberg's students, and Contaigne is the one who's filming, and Rob is over there. And so welcome to the Dahlberg Lab. Over here we have our fish tank with the fish, and also our advisor's motto, which is do every experiment as poorly as possible. And what this means is that you just should do what you can to get the experiment working, and then make modifications afterwards to make it better and better. Because if you spend a whole year or a couple of years working on something and making it perfect, and then it turns out not to work, you'll be very sad. And so back here is an example of one of these wonderful patches where this contraption pours liquid nitrogen into this dewar, and it will work.
Over here is my setup. I measure permalloy square dots, and then I put a magnetic field across them. They want to either point, if you have your dot, they either want to point up or horizontally. And then I actually watch, if you tune the magnetic field correctly, thermal excitations will cause it to flip back and forth between the two states, which is something called random telegraph noise. And I measure that at various temperatures here in my cryostat.
So here I'm using this setup to measure the AC susceptibility of a weird magnetic material called spin glass. It's a pretty boring rock, but its interactions make it really interesting and confusing and exciting and weird to study. And so Contaigne also studies spin glass, and we study two different facets of it so we can compare it.
Okay, so I'm also measuring the spin glass. But I mean, compared to Jenna, I just use different approach. I measure the spin glass device through the one-off ethanoids. So basically, you can see here is the cryostat I'm using. So this one is the dry fridge. So basically, you don't need to frequently pour helium into this fridge. That saves you a lot of time. And okay, and this is also a fancy locking amplifier. So this one, the special thing of this one is you can access to all of your data and control this locking amplifier through the web browser, for example, like Safari or Google Chrome. Good.
Yeah. This is one of our more special pieces of equipment we have. There is another one of these in this building, but it's shared by everyone in the building. We have one of our own. This is a sputtering machine. What it's for is we use it to make samples. So I use an electron beam to draw out shapes in a substrate, and then we use this to then deposit atoms into that space, and then I remove that substrate layer, and I can make whatever shape I want. It's very small sizes. So what this does is this produces a large voltage, and we fill this with a tiny bit of argon. That argon will bombard a metal plate, release some of those metal atoms, and then deposit them on our sample. And if you come close here, hopefully it'll show up well on the video. You can see here that it's actually producing a plasma. That's how fast the argon is coming down.
And then up here we have champagne bottles. So what happens is every PhD student who graduates gets one of these, and it turns out that it's nice fancy champagne. So